how are you? So we are going to start the separate series which already we have done in Hindi segments for AVR Studio tutorial or AVR Atmega 32 or 16 microcontrollers. So what we are going to implement in this segment, that in the same way we have done in Hindi. What we have done, what we are going to start, we are going to start with LED blinks here. After that we will configure the switch. We will going to use UART, I2C, SPI protocols and many more to come. Okay, so it may be your on demand projects codes, or it may be for your solution you are going to think a separate mode of solution for electronics, which is totally depends upon MC programmings. So we are going to study in full details about programming in our code sections. Okay, so what is the new thing in this tutorial? Okay, so new thing is that in Hindi we did not uh, given the software codes for that, but in this tutorial, in this segment, we are going to support you fully by software, by design, by coding, by elaborations. Okay, so you can directly download the code from our link, which will given in the descriptions, where these codes are available. Okay, so this code will be available on blocks. Okay, so electronics for us, you can say, is already created a blog for you, and you can download that tutorial from that. Okay, you can download the software from that. So here we are going to start. So you can see the screens that 8 LEDs are connected on port A, which have 8 pins in AVR3216 40-pin microcontroller. There are 4 ports: port A, port B, port C and port D. Each and every port have 8 pins, starting from A0 to A7 and B0 to B7 and so on. Okay, so you have to if you going to write the software, you just have to fully understand about what is the hardware features of these microcontrollers. So in the separate video we are going to make for your hardware descriptions, for your understanding of how you can remind the all port positions. Okay, so we are going to make after means this tutorial, or you can say in upcoming tutorials. Okay, so for that, before the starting the software code, I just request you to please subscribe our channel and fully support us, so that our team can work more dedicatedly for you. Okay, so let us start. Please subscribe my channel, likes. If you have any doubts, please comment. I will reply soon. Okay, so starting from the software. Okay, I'm going to just stop this simulation. I'm here started the AVR Studio. Whichever version, you can write the same code for that. Okay, it may be some compilation issue, or maybe some porting issue from one software to other, but the LED blink code or most probably codes will be work for the same if you write manually. Okay, so let's create the first project. You have to create from file, choose the option new, go for the project. Okay, so here the first option we have to choose is AVR executable projects. uh, Below is library, so you don't look for that. Okay, so choose the executable project. Here you can select your project name. Okay, so I am going to select my project name is as LED blink. Okay, I can say 2. Okay, and the what will the location, you can browse from here. Okay, so here already 2 projects are there. So in this project I am going to select is from select folder. Okay, So the same will be the locations, my locations. Your location can be different, so choose your locations, and by clicking OK you have the window for the microcontroller selections options. Okay, so in this case microcontroller is Atmega 32. Okay, or maybe it's 16, both will be the same for simulation. So the first one we can select. Here you can download the dataset, but currently we don't need this. But in the separate video I already discussed with you that in hardware configuration I am going to explain about dataset. Okay, so by clicking OK you have a separate window for that. So I am going to remove all the unwanted contents. So you can see here. So this is the header or library, you can say areas, or you can define the global variables here. Here is the user code, application code, which you are going to run in while. Okay, so here I have removed all the unwanted things. So what you have to look, you if you are working on hardware on the same for the same MCU, you have to define everything properly. Otherwise it may be it sometimes you look that it is working, but after some time it may be hang. Okay, so for that everything, every peripheral functions, every properties we have to write properly. Okay, so here I am going to define first the frequency of MCU. Okay, so what we have to select FCPU. Okay, FCPU. So what FCPU is? FCPU is the frequency of the microcontroller, operating frequency, you can say that operating frequency of the microcontroller. Okay, so what is the operating frequency of microcontroller? It is already given in the datasheet. So as for my session it is started with 1 megahertz. Okay, 1 megahertz means from started with 1 megahertz you can select up to 8 megahertz, or you may refer to the dataset. So for this tutorial we are going to choose 1 megahertz. So on for 1 megahertz we have to put 60. Okay, so it will be 1 megahertz. After that two things are already defined. So in this tutorial I can write here, it is the MCU operating frequency. Okay, operating frequency. In second line you can say this is the IO means input output. Okay, definition you can say that of ports or AVR ports. Okay, here you can get the definitions. Okay, after that one library also we are going to include one header, you can say. Okay, is util delay. What is util delay? In util delay the delay functions or more functions are available. So I am going to here select the delay functions. For what you can say, you can run the simulation and you can say here for 1 second of delay. After 1 second of delay the LED is going to blink. Okay, so for that we have to select the delay functions. Okay, so after that for programming, look, there are two registers. First one is DDRA. Okay, DDRA, the full form is data direction register. Okay, what is A? So I am going to remove the A portion and here writing X. So what is X? X is for the port numbers, which is A, B, C and D. Okay, So in simulation you can say LED is, what is LED? LED is input or output. So LED is output device, output peripheral, you can say indicator. So for that we have to give direction of that port, means the port LED is connected on A port, so I am selecting here DDRA. After that you have to put B suffix for binary if you are going to put all values in binary. If you are going to put in hex, so you have to add the here 0x. So I am going to put 0b. As you know, every port has 8 pins, so you have to select that whichever pins, means if you are going to only operate one pins, if you are going to only configure two pins, you have that options. So here we are actually we have connected 8 LEDs in all pins of port A. So we are going to make it as output. For output you have to select one is for output and 0 for input. Okay, after that we have selected already, you have given the directions for the port. So what we have to go in while. Why in while? No, while always true, you can say always true means every time it will run until we stop it manually or by interrupted. Okay, after that in while we are going to on and off the ports after every 1 second. So port is the port registered, you can say you have to write from port A. Okay, so from port A, here we are going to already have discussed that for output. So there are 8 pins, you are going to put that 8 pins high. So for 1 is high, 0 is for low. Low means off. Okay, so high and low will be blink how after how many delays? By delay of 1000 millisecond. How do you know that this is millisecond? Because we have chosen a function of delay of ms. Ms means millisecond, so 1000 millisecond equal to 1 second. So here you can select that. Okay, after port A high for 1 second, we are going to low it for 1 second. For low you have to put 0. Okay, so you can say all port all pins are low. Okay, and after that after 1 second of low, then port will be high. Okay, so you can say here in first step, if you are scanning from the top, we have given the direction for the output. Here we are going to high all the pins after for 1 second. After that we are going to load all the pins for 1 second. So every 1 second it will be repeated. Okay, so after that the build option on the top, you can select by shortcut F7 or by direct clicking on build solutions. So here you can at the bottom you can say, you can see here once succeeded means this project is built successfully, 0 failed, there is no error. Okay, so by the building of this project, the hex file is already created on that debug files of the project. How you can see that? So we have to find on the project locations. Okay, so we are going to find, you will see. Okay, so coming with these files. Okay, so here you just imagine that the microcontroller is blanked out, there is no project dump, there is no hex file dumped on this MCU. So double click on MCU, select here from the folder location here. Okay, so search your product. So here at the top you can see your project name is LED Blink 2. Okay, so from that here is the folder LED Blink 2. In debug file you can say hacks. So this hacks we have to dump on the MCU, and MCU will take it all the configurations that software you have done. Okay, so click OK. So code is already dumped in the solution. In the same way you can dump in the hardware by means by flash, by debugger, by the same method you are going to write. Okay, after that I'm just running, you can say playing. So you can see here the port is blinking after every 1 second. If you if let's suppose if I did not connect it these LEDs, so here you can say here on the pin numbers it is going high and low for 1 second. If you connect it will be indicate, otherwise on that way you can also debug. Okay, so this is the basic software code. So the code will be available in the description link, and you can directly download from that. We have created a new web blocks for that. So we are going to means write or more information on that blog, and in future it will you will get more features on that. Okay, so okay, so this is our code, this is our tutorial. So I request you to again to subscribe my channel, and share the links for your friends, for your professional friends, for your student friends, whoever is want to learn about more about electronics. So if you are a Hindi or maybe from Indian or from India, the already these tutorials are available in Hindi, you can learn from that. Okay, so thank you for watching, thank you for supporting, keep supporting us.